Alrighty, we got a really interesting discussion today on multi-chain infra. I am Emily Huck. I will be moderating this panel today. I'd love for y'all to introduce yourselves, tell me what you're working on, where you're working, all that good stuff. Julian, you want to start?
Yeah. So I'm Julian. I'm leading new integrations here at LeFi. LeFi is a cross-chain aggregator and the most used liquidity venue for cross-chain transactions. We are an infra company. We also have our front end, which is Jumper. Nowadays, we are powering more than 600 enterprise clients and helping them with their cross-chain needs for swapping and bridging. Yeah, I'm from here, from Buenos Aires. So happy to have this event here in my own city.
Awesome. Thank you.
Hey, thanks for having us. My name is Lucian. I'm from Boundless. I head the integrations team. And what Boundless does is it's the backbone of ZK. What we do is we create zero-knowledge proofs that can be requested on any chain, and then you get a guarantee that it could be submitted on any other chain. And one of the things that we did when we launched is we built the first ZK Ethereum consensus client, which lets you then prove any arbitrary state that is on Ethereum on any other chain with just a zero-knowledge proof.
Hi, everyone. I'm John Jones, co-founder of Supra. Supra went live on mainnet last year, and we are a multi-VM chain, but we went live with our Move mainnet. So after Aptos, it's Supra. We are the third Move-based chain to go live. And we are a multi-VM platform. So we have Move on mainnet. EVM is now on testnet. And we have some interesting, kind of news recently where we have this $1 million bounty that proves that we have the best parallel execution of any EVM. So that's now on DevNet. So EVM is on DevNet, and we're hoping to have Solana VM early next year, maybe Q1. Yeah.
Did you say $1 million?
It's $1 million bounty, and I'm a co-founder. My other co-founder Josh, he was really insistent on this bounty that he was willing to put his own tokens on the line for this bounty. That's how confident we are. Actually, it's $1 million bounty. So
again, $1 million. Everyone should be listening. Ronaldo.
My name is Ronaldo. I've been in crypto for a long time and joined Aptos this year, working heavily on payments. Aptos is the fastest blockchain in production right now, fastest at scale. It was built by the core developers of the Meta SDM and Libra project. We are one of the leads blockchains in our RWA and on-chain value. We have over $700 million in on-chain value on RWA. And we are one of the lead chains on stablecoin liquidity, USDT, USDC, USDE, and now recently USD1. Aptos' three main verticals right now is decentralized data storage through Shelby, global trading engine, mostly through the Decibels project. And we are heavily expanding in payments as well, which is the team that I'm working on right now.
Awesome. So we got a wide array of expertise and areas of development in blockchain. I'd love to know what specific gaps are y'all solving for in your projects, and how are solving those gaps going to make on-chain experience better, and how can we all work together to do that? Whoever wants to start can roll with it.
I think we as a layer one, I think the biggest gaps that we have right now is everyone is moving toward like utility, bringing crypto for allowing payments, for allowing cross-border money transfer, settlement. And one of the biggest gaps that we have, it's around the difference, the fragmentation and difference around each chain. Every chain has its own finality, its own gas fees, its own complexity. So around what we are talking here today, one of the toughest points is the coordination and creating multi-chain infrastructure for communicating in between chains is this diverse fragmentation. And Aptos' main focus on trying to solve this and is around consistency of execution and trying to reduce as much as possible the finality. So then this removes a lot of this uncertainty around the every protocol that is connecting two chains, that is some kind of consensus protocol like EigenLayer or every bridge. The chain that has the smallest finality, you can have in the shortest period of time, you can guarantee that execution committed, and then you can move to the next hop. So that's one of our main focus. This is also around the data storage with Shelby. We try to bring super fast and verifiable data structure in a replicated way. That is the nature of the distributed data storage, and also verifiable data. So that's where our main focus are.
So storage and finality. Did I hear that correctly?
Finality, extremely high throughput, and most important, stability at scale. So Aptos has proven super high scalability and keeping the same finality.
Got it. Thank you. John?
Yeah, so I think some of the biggest problems that we're solving are one, multi-VM capability, two, MEV value capture and keeping it within the ecosystem, and maybe three, when you're talking about interoperability, cross-chain communication is something that we're focused on. So for one, Supra is multi-VM. So we're bringing the fast finality from Move, and we're bringing that to EVM and then also to Solana VM. And then the second problem is MEV, kind of like avoiding toxic MEV and also good MEV being extracted away from the ecosystem and away from DeFi. We use what's called kind of native automation, and we have native services in Supra that really try to keep the MEV or the good MEV within Supra and also try to prevent toxic MEV. And we have different ways that we benefit applications on Supra by kind of sharing that revenue or that value extraction. And the third one is that Supra created something called Supranova, which is a cross-chain, it's like a bridgeless solution. We use our layer 1 and our validator set to actually act as a bridge. So it's kind of a bridgeless cross-chain communication protocol. And we do something really interesting. It's actually quite simple. On proof-of-stake ecosystems, we can actually, the validator sets. And so basically what you can do is you can just recompute the consensus on those proof-of-stake systems, and you can actually know, and you can basically create a trustless bridge by recomputing that consensus. And that's what we do with Supernova. And so hopefully we're planning, we're bridging between Supra and Ethereum now, but we'll be bridging to Aptos and other networks as well. And we think that this bridge, without using a third party to help bridge these assets and kind of have the security and the shared security of the layer 1, is really quite enticing for builders and also for just retail in general. So those are the three things that we're focusing on.
Super helpful. Thank you. Lucian?
So to explain where Boundless fits in the ecosystem, I have to kind of explain what the role of ZK is more generally in blockchain, and it's mostly in scaling and privacy. With regards to scaling, ZK is effectively a compression function for blockchain. It's the only way to actually increase throughput of a blockchain node without increasing the hardware requirements. And you do that with off-chain computation, and that's what Boundless does. We basically brought more GPU proving capacity online now for ZK than has ever existed before by introducing something called proof of verifiable work, which turned ZK proving into proof of work. So the way that it's used in interoperability is the same way that you would essentially re-execute the validator sets of different blockchains. We would re-implement the consensus protocol in ZK and just compress that computation. And then all you have to do is post a Groth16 proof on any chain that replicates the signatures of validators. So it turns a blockchain into a portable information set, and you're able to post updated block hashes on any other chain. Then lastly, it's still a zero knowledge protocol. So we at Boundless, we started out as Risk Zero. Risk Zero built the first RISC-V ZKVM. And what happened was essentially a Cambrian explosion of developer velocity in building ZK applications. You can now write any Rust code, compile it with our ZKVM, and build a zero knowledge proof of it. So rather than spending years building a custom circuit that represents a single blockchain. You just write the Rust program that represents that chain. And as we've seen recently with Vitalik's talks about the future of Ethereum, almost all of it is started under the assumption of ZK VMs, because now we could actually port over all of the existing code bases of different blockchains into ZK. So the last part that I wanted to talk about was privacy. Because we have this developer velocity and this ability to build zero knowledge proofs quickly and get them to market quickly, we also have the ability to meet the changing regulatory environment required for having on-chain privacy. So there is no regulation for what on-chain privacy looks like, but when it will be implemented, our development stack is the fastest to be able to get to market with a ZKP to enable privacy on any other blockchain.
And so, just to clarify one thing, ZK proofs. Now I don't know what I'm
So
asking.
the best way to think about ZK, just as like a rule of thumb, it's a compression function for computation. So if you run like an entire blockchain client in our ZK VM, you get a very small, very cheap proof at the end that the computation was done correctly.
So
So
could
then
you
you don't
put
have to re-execute it like a validator. You just have like a very lean, a lean
Yeah.
representation of that execution.
Got it. So could you put like a few Aptos blocks through ZK and get the same
Yeah.
output?
Actually, we do have an Aptos-like client, so we have a way to prove Aptos blocks in ZK, and then we can do something that's called an inclusion proof. But basically, it's like you prove that the block header is this, and then you can say that as a bridge, I deposited here. Here is my proof inside of Aptos's consensus client. So you're able to actually build truly permissionless bridging for the first time, in which our security properties essentially match the same security properties as the blockchain itself, plus the trust in the zero knowledge cryptography, and no additional assumptions, no trusted relayers, none of that.
Wonderful. Julian, what are you guys working on?
Yes. Well, the problem we are solving is pretty easy to understand. So we are solving crypto liquidity fragmentations. So nowadays there are hundreds of blockchains, and there are 100 more coming in the next couple of months for sure. So in the end of the day, it's hard from a user perspective to perform or to move assets across all these different chains. So what we are basically doing is connecting all of them. We started doing it by aggregation of single bridges, DEXs, DEX aggregators. Nowadays, we are also launching our own intent system, which is like the latest in terms of interoperability and bridges. And we pack all of that in a single API. So our partners can basically connect to our API, and the users can perform cross-chain swaps across over 60 different networks nowadays.
Wonderful. I am very new into crypto. I've only been in this space for a little over a year, and there is nothing that irked me more when joining this space than bridging and trying to figure out why certain assets only belong on certain chains. So though I know very little about this topic, I'm extremely passionate about it from a user experience perspective. Thanks, y'all, for those answers. Where do you think things often fail in production today when it comes to cross-chain interoperability? And how are you addressing those failures in your current builds?
I've been working on a bridge before Aptos, so it's a problem that I enjoy a lot. One of the biggest issues that we had on bridging was if the price changed in between the travel rule from when the funds were acquired on the source chain and moved into the destination chain. One of the biggest issues is like what you do with the asset when it arrives on the destination chain if there is no liquidity anymore of the price change. Who eats that cost? The way we were solving that, it was basically paying the user with the token, the stablecoin that we were able to move, and delegating the risk. That was on the user terms. I think one of the biggest issues around the bridging, it's the coordination in between all the pieces. You usually have like a messaging protocol that is a consensus layer. If you control the capital on the two chains, is a different story. Then you can perform the mint and burn. It's way easier, the complexity. But if you're routing a message to a messaging protocol and relying on liquidity from someone else, then the complexity is exponential. I think LiFi are dealing with those kind of issues right now.
I think a big issue, like for us, like I talked a little bit about our consensus, our cross-chain protocol, Supernova. We do, we recompute the consensus of the other chains we interact with, and we have a pretty efficient movement of assets among layer ones. But when you look at layer twos, whether they're on Ethereum or any other ecosystem, there's definitely an issue with being able to have assets move efficiently and quickly. And so for Ethereum L2s to be able to bridge asset from an L2 to Supra or Aptos, there's a lot of latency, security assumptions, and like for the end user, it's quite difficult. It's quite
It's the worst.
it's not easy. It's a nightmare. But imagine like even for like AI or like an agent that wants to be able to move assets, it's also not easy, right? So what if you have an AI agent that's operating in DeFi that's trying to move assets, find the best liquidity? That AI agent might be dissuaded, might not be incentivized to operate in the L2 world because of how inefficient it is. So I would just say like from layer one to layer one cross-chain communication, I feel like we're there. Like things are pretty good. But when you have the L2 world, whether it's on Ethereum or other chains, maybe a Solana L2, there's a lot of complexity and inefficiencies that would hurt the like end user's experience, but also like an agent experience. So I would just say like, I'm kind of on Super, we're fans of, we're kind of on the L1 team, and it's because of the cross-chain messaging efficiency and avoiding the inefficiencies of the L2s bring.
And Supra building out the SVM, EVM, and Move VM will make that all a lot more seamless between L1s and L2s.
Well, it'll definitely make it seamless within our ecosystem to allow developers to build on different virtual machines, but also just in general, like being able to bridge asset from a virtual machine on Supra's layer one to another L1. That's fine and that's efficient. It's when you get into the L2 world is when it just gets more complicated.
Yeah. Lucian?
Well, we also prove L2s. So the solution to that is actually running L2s in validity mode. And the long-term vision of it is actually to move L2s to something called based rollups. The amount of Ethereum research that is required to execute on this vision is substantial, but it's all ZK focused. Essentially, the issues with L2 interoperability is the fact that finality on Ethereum, where a potential reorg can happen, is not instant. So the things that Ethereum needs to do to be a better interoperability layer is to have single slot finality, and L2s need to have validity proving, because as soon as that proof is on chain, the chain is finalized. Then you have the ability to have atomic interoperability within L2s with the full trust assumption of Ethereum. There's a lot of work in this direction, and it's a lot of ZK proving, which is incredibly bullish for Boundless to solve.
Where are we failing, Julian? Help us out.
So we have many different challenges on what we are doing because depending on the different use cases that we have, we're gonna face different challenges. So companies that are using LeFi, for example, for payments or only for bridging stablecoins, they're gonna face issues probably more related with the time and the velocity and of the settlements. And instead, on the other side, DeFi protocols or big wallets such as MetaMask, Phantom, Binance, they are all using us for swapping and bridging. And I will say probably the problems there are slippage issues on the different chains because of the liquidity. So yeah, I will say that depending on on the different use case, we face many different challenges. The good thing is that we are all the time trying to improve and improve us in terms of our customer relationship management, and then also with our liquidity providers to improve all these routes. Because in the end of the day, we want to make it easy to move any asset from any chain to any other asset on any other chain. But yeah, it's not an easy task, of course.
It's not. So we've hit on it a lot. I think, all of our different L1s, L2s protocols are all their own special snowflakes. They all have different latency times and aspects to them. So how do you ensure that you support their requirements as you work to integrate new protocols and pieces to your projects? And make sure, like, if they don't have the same standards as what your project has, how do you help them get up to speed, or how do you work them to make sure that it is interoperable? Julian, do you want to start?
Yeah. So transparency is like the first thing. Of course, we try to improve our routes all the time. We are doing huge maintenance because we are also calling different providers at the same time. In the end of the day, we are a router and we call different providers. What we try to do is to be super transparent and to be super clear with our communication, also with our documentation. Our development team, sorry, our devs have done a great work on our docs. And that's super important. We have 3 different ways to integrate LeFi nowadays, and we always receive good feedback about the 3 of them, because it's super important to have a good developer experience. In terms of, I mean, if I will be on the other side, I would love to have like something clear and easy to integrate into my wallet, into my protocol. So yeah, I would say that that's the most important thing right now.
Transparency is the most important thing.
Transparency, communication.
Yeah. Concur. Lucian?
The way that we integrate is very different. It's primarily because we're one of the few projects that are actually a supplier to other blockchains. We're a core cryptographic primitive, and we can integrate with EVM chains, non-EVM chains. As long as you support the underlying cryptography, we can work with basically any chains, even chains that don't have smart contract capabilities at all. Um, there's even ways to actually make our protocol work on Bitcoin as well using BitVM2. We have a couple teams launching. A lot of people have to try to make different execution environments interoperate, right? By adding them to the same protocol. We just need people's code to compile to RISC-V. And that makes it actually really easy. And then we have the ability to recurse programs and then make them interoperable just by the design of how we do things. I think the most difficult part of integration is the fact that the computation is done off chain. We don't have validators re executing transactions. It's actually just a different way to think about it. And that's why we built Boundless. We wanted to build the most blockchain native way to request off chain computation. And then you get a proof, you get a guarantee that someone will fill that request and submit it on chain on your behalf, so that you could have a similar interaction design pattern as most application developers are used to. But generally, we've been focused very heavily on integrating with a lot of blockchains, and the design pattern on how you use us in bridging in Solana or on Ethereum is essentially the same. And that's kind of unique and different relative to having to accommodate for all the differences different chains have.
Yeah, I saw an article. You're talking about RISC-V, where I saw an article where Vitalik's talking about like potentially RISC-V could be the way that Ethereum brings multiple virtual machines to Ethereum. So in the article, he did mention Move, right? So maybe Move could be the next contender to bring to Ethereum. You'd have the RISC-V framework with, then you have Solidity and you have Move, and you probably have different versions of Rust. You also mentioned about cryptographic compatibility. That was an issue for us in the past. For example, Solana's cryptography is a little bit different and not as compatible as like Ethereum or Aptos, Supra, we all have like very similar cryptography. And Solana was kind of like one of those outliers, whereas like a little bit difficult to prove, the cryptographic proofs. But I think they're actually switching, and so that maybe that problem won't exist in the near future. But yeah, I think that was probably I was going to mention the cryptographic compatibility is really important, and when it's incompatible, that becomes a pain point. But yeah.
I think we handle that mostly, as Julian mentioned, through transparency and predictable execution on chain, mainly because of our programming language, the type safe on the move language, and also this applies also to our data storage project with all the data you can verify and guarantee. I think it's about transparency and being able to predict precisely what is going to happen with the execution and then commit or roll it back for us as a layer one protocol.
Makes sense. So we are towards the end of this. I'd love to hear if any of you guys have some hot takes, either about this topic on multi-chain infra, about what's going on with Ethereum and what might be coming next. Anything you want to talk about or share? Whoever wants to take it. I see Joe.
I'll
John.
take it. And this doesn't sound like a hot take because this is multi-chain day, right? So I don't know if this is such a hot take, but we, at Super, we believe the future is multi-VM. And also, I think Vitalik also realizes that as well with, figuring out, well, let's create a framework to have multiple virtual machines on Ethereum. So I don't know if it's such a hot take anymore. It used to be. We're at multi-chain day and we're talking about multiple VMs, but really the future is multi-VM. I would say another hot take is really like, yeah, you need layer one to layer one efficiency in terms of cross-chain communication. So it'd be great if Ethereum could solve those issues with L2s. And I guess the final hot take is, well, I can announce the bounty again, but Super has $1 million bounty on the line that basically we have the code where you can run the code and try to prove that Super doesn't have the fastest, best parallel execution. And so basically, we're saying that we have the best parallel execution on a EVM at the moment. So it's $1 million bounty. Check it out on our Twitter, and we're hopefully no one claims the bounty and proves us wrong. But if they do, we'll want them to join our team. I think that could be a good opportunity as well. So maybe it's a win-win.
So it'd be a really hot take to say that I'm going to disprove Supras.
It's not actually a hot take. I think it's talking about multi-chain interoperability. I think we lack a lot of standards, mainly around layer one communications. Layer two is another level of complexity. So some kind of standard for, as an example, the way we deal with liquidity these days, there's high cost of the liquidity fragmentation, the liquidity being stuck on behind some like gigantic yield protocols. I think some optimization should be done at this level where it becomes easier to bounce liquidity around in between layer ones in order to be more capital efficient. I think it's not actually a hot take these days, but I think it's something that we are struggling with being more efficient on the way we deal with the capital being stuck and basically not frozen, but like stuck on a new protocol generating some revenue where it could be empowering like dozens of protocols. So I think there's a lot to explore in that area.
Absolutely. Lucian?
The way people typically think about bridges or application specific blockchains, they think of like, oh, my funds come from here and they go to there. If you can actually prove the origin of funds from multiple chains within the ZKVM runtime, you actually don't care where they came from. So you can accept deposits like Lighter does currently from Ethereum. We have a project doing something similar. Their name is Malda, and they accept deposits into a lending protocol from 6 different chains simultaneously. And you basically need a validity proof in order to withdraw from the protocol, but deposits are instant. And then you are able to essentially access and commingle liquidity from multiple chains within the same application runtime. And I think that the future of application development is leading towards an actual consolidation and aggregation of liquidity, because the arbitrage opportunities that have existed because of the latency of traditional bridging, it's going to be taken away by a new class of application.
Yeah, I think just to add on this, I think the liquidity is something that is tied to the consensus. I think sometime in the future is gonna evolve in a more like an Oracle approach, where liquidity is splashed on chain, it's available anywhere, and is pooled by who needs it. So more in real time instead of being. It's part of the consensus, so a lot of changes are required, but I think there is a lot of space for like gigantic improvements in this area.
Yeah. So the way we see this is that this problem is becoming bigger and bigger, and there are new players as well coming along with all these new problems. That's why we are working with the Ethereum Foundation in a framework for interoperability. We have spent last week at Edge City with EF. We have basically built a technical framework for bridging and performing transactions. We actually performed the first transaction under this framework last week. We're building this with the EF and different teams involved in the Interop ecosystem. So it's a good time to create a good framework and a standard for interoperability, because if not, this problem is going to become bigger and bigger, and all these different players are going to choose their own solutions, which in the end of the day, I mean, they are free to do it, but it's not the best way, because you're gonna end up having like a fragmentation not only of liquidity but also of different systems. So that's why we decide to start working on this open intent framework with the EF. And yeah, I'm looking forward to see this adopted across all these different bridges and solutions.
The industry is moving so quickly that these hot takes become not hot takes very quickly. And we got a lot of hard problems to solve. But thank you guys so much for chatting with me about it. It's been really fun. Have a good one.